Dear listeners, welcome to this extraordinary adventure through the stars. Have you ever gazed up at the night sky, that endless canvas of twinkling lights, and wondered if we're truly alone in this vast universe? Imagine, just for a moment, that the heavens above aren't just filled with familiar stars and planets, but occasionally visited by wanderers from distant realms. Mysterious travelers that have journeyed across billions of kilometers, crossing the boundaries of solar systems to grace our little corner of the cosmos. Well, my friends, that imagination became reality on July 1st, 2025. That's when astronomers peering through powerful telescopes in the clear skies of Chile spotted something unprecedented. A faint streak of light hurtling through space, unlike anything we'd seen before. They named it Through-Eye Atlas, the third confirmed interstellar object to enter our solar system. But is it merely a comet, a frozen rock ejected from some alien star system eons ago? Or could it be something more? A probe from an advanced civilization silently observing us as it passes by? Join me on this 2-hour journey, where we'll trace the path of Three-Eye Atlas step by step, unraveling its secrets like explorers charting an uncharted galaxy. We'll dive into the science, the speculation, and the sheer wonder of what this visitor might mean for humanity. Picture yourself strapped into a virtual spaceship, zooming through the void as we ask the big questions that challenge both our imagination and the frontiers of science. Are you ready? Let's launch into the unknown. First, let's set the stage by understanding what makes Three-Eye Atlas so special. In the grand tapestry of the universe, our solar system is like a cozy neighborhood in a sprawling cosmic city. Most objects, planets, asteroids, comets, are bound by the sun's gravity, orbiting in predictable paths. But every now and then, a rogue visitor from another neighborhood, another star system, wanders in. These are interstellar objects, or ESOs, and they're incredibly rare. Before 2017, we hadn't confirmed a single one. Now, with advanced telescopes like Atlas, we're spotting them more often, each one a messenger from the stars. Three-Eye Atlas was discovered by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, a network of telescopes designed to scan the skies for potential threats to Earth. On that fateful night in July 2025, the system picked up a dim, moving dot against the backdrop of stars. At first, it looked like just another comet or asteroid, but as data poured in, astronomers realized this was no ordinary rock. Its trajectory screamed outsider, a hyperbolic path meaning it wasn't orbiting the sun but slingshotting through our system on a one-way ticket from interstellar space. Imagine the excitement in observatories around the world. Scientists from NASA, ESA, and independent researchers scrambled to point their instruments at this newcomer. Headlines flashed, "Third interstellar object spotted." Social media buzzed with speculation. Is it natural? Artificial? A sign of alien life? As we embark on this podcast journey, we'll explore all these possibilities, painting vivid pictures of cosmic wonders along the way. To truly appreciate Three-Eye Atlas, we need to meet its predecessors, the first two interstellar visitors that paved the way for this discovery. Think of them as the trailblazers, the scouts that alerted us to the fact that our solar system isn't as isolated as we once thought. We'll dive into their stories next, building the foundation for our adventure. But before we do, let's pause and let the enormity sink in. This object has likely been traveling for millions, perhaps billions of years, born around a distant star, flung out by gravitational chaos, and now, by some cosmic coincidence, it's here, in our backyard. What tales could it tell if it could speak? Hold that thought as we begin our first leg of the journey. Now that we've launched our cosmic voyage, let's turn back the clock to meet the pioneers, the first two interstellar objects that captured the world's imagination and set the stage for 3 Atlas. These aren't just rocks or ice balls, they're ambassadors from other stars, each with a story that challenges what we know about the universe. Our journey begins in 2017 with the first confirmed interstellar visitor, one Oumuamua, discovered by the Pan-STARRS telescope in Hawaii. Oumuamua, a Hawaiian word meaning scout or messenger from afar, was a complete surprise. Picture this: a cigar-shaped object, roughly 400 meters long and only 40 meters wide, tumbling end over end through space. It had no tail like a typical comet, no outgassing of ice turning to vapor under the sun's heat. Instead, it accelerated slightly as it left our solar system, defying expectations. Scientists were baffled. Was it a fragment of a shattered planet from another star? A chunk of exotic ice? Or, as Harvard astronomer Avi Loeb famously suggested in his book Extraterrestrial, could it be an artificial probe, a light sail sent by an alien civilization? Loeb pointed to its unusual shape, flat like a pancake in some models, and the non-gravitational acceleration, which could be explained by solar radiation pressure on a thin manufactured surface. The debate raged. Mainstream astronomers argued it was natural, perhaps hydrogen ice or a nitrogen slab from a Pluto-like world. But the mystery lingers. Oumuamua sped in from the direction of Vega, a bright star 25 light-years away, at 26 kilometers per second, fast enough to cross the distance from Earth to the Moon in just 11 hours. Imagine the global excitement. Media outlets dubbed it the alien cigar. Conspiracy theorists claimed it was scanning Earth for signs of life. Even NASA redirected telescopes like Hubble to study it, but it was already fading into the distance by the time we fully reacted. Oumuamua taught us a crucial lesson. Interstellar objects can sneak up on us, and we need better tools to catch them early. Fast forward to 2019 and enter the second visitor, 2I Borisov. Discovered by amateur astronomer Gennady Borisov in Crimea using a homemade telescope, this one was more comet-like, a fuzzy ball with a visible tail of gas and dust as it approached the sun. About 2 kilometers across, Borisov came from the direction of Cassiopeia, traveling at 30 kilometers per second. Unlike Oumuamua, it behaved like a classic comet, outgassing carbon monoxide and water ice, creating a coma that made it glow. But here's the twist. Its composition was odd. Telescopes like Hubble and Yiso's Very Large Telescope revealed high levels of carbon monoxide, more than typical solar system comets. This suggested Borisov formed around a cool red dwarf star, far from our Sun-like G-type star. It was a pristine snapshot of another solar system's building blocks, untouched for billions of years. Borisov sparked less alien speculation than Oumuamua because it fit the comet mold, but it still ignited wonder. Scientists modeled its journey, ejected from its home system perhaps 1 million years ago by a gravitational kick from a passing star or planet. As it swung past the sun in December 2019, it fragmented slightly, adding drama to its visit. We watched it leave, knowing it would never return, carrying secrets of distant worlds. These two trailblazers, the enigmatic Oumuamua and the classical Borisov, prepared us for what came next. They showed that interstellar objects aren't rare anomalies, but regular cosmic nomads, potentially numbering in the billions across the galaxy. Each one is a time capsule, a piece of another star's family wandering the void. And now enter 3I Atlas, the third in this elite club discovered in July 2025. Named after the Atlas survey that spotted it, this visitor stands out for its brightness, its retrograde orbit, and the tantalizing hints of something unusual. Unlike its predecessors, 3I Atlas is larger, brighter, and its path brings it tantalizingly close to key planets in our system. Is it just another comet, or does it hold clues to extraterrestrial technology? We'll explore the moment of discovery next, as our journey accelerates. Think of Oumuamua as the mysterious stranger who knocks and vanishes, Borisov as the chatty traveller sharing stories, and Thrus Atlas as the bold explorer lingering just long enough to intrigue us. What secrets does it hold? Let's find out. As our cosmic adventure continues, let's zoom in on that pivotal night, July 1st, 2025, when the skies revealed their latest secret. It's a story of human ingenuity, cutting-edge technology, and a dash of luck, reminding us how far we've come in peering into the universe's depths. At the heart of this discovery is the Atlas system, the Asteroid Terrestrial Impact Last Alert System. Funded by NASA and operated by the University of Hawaii, Atlas is a network of telescopes designed to scan the skies for near-Earth objects that could pose a threat. With sites in Hawaii, Chile, and South Africa, it surveys the entire visible sky every 2 nights, hunting for asteroids, comets, and anything else that might cross our path. Think of it as Earth's vigilant guardian, a digital watchtower against cosmic surprises. On that clear night in Chile, at the Atlas telescope in Rio Hurtado, observatory code W68, the system captured a faint streak of light moving against the starfield. At first, it seemed like just another dot in the data, one of thousands Atlas detects daily. But as algorithms crunched the numbers, alarms went off. The object's motion didn't match any known orbit. It was coming from outside, way outside. Astronomers quickly mobilized. The Minor Planets Center, the international hub for tracking small bodies, received the data and confirmed this was no solar system native. Its hyperbolic orbit, a path with eccentricity greater than 1, meant it wasn't bound by the sun's gravity. Instead, it was slingshotting through, entering from interstellar space at a speed of about 30 kilometers per second and destined to exit forever. The name 3I Atlas was born. 3I for the third interstellar object, and Atlas honoring its discoverers. Also known as C2025N1, Atlas, it was initially designated A11PL3Z before confirmation. News spread like wildfire. NASA announced it on July 2nd, 2025, with animations showing its trajectory. Social media exploded. Nukta 3 Atlas trended, with memes comparing it to sci-fi invaders or lost space probes. But what made this discovery so thrilling? Unlike Oumuamua, which was spotted outgoing and fading, or Borisov, seen inbound but distant, 3I Atlas was caught early, giving us months to study it. Telescopes worldwide, from Hubble to the James Webb Space Telescope, JWST, turned their eyes toward it. Initial images from Hubble on July 21st showed a bright coma, a fuzzy halo of gas and dust, suggesting active outgassing. Personal reflection. I remember reading the first reports and feeling a chill. In a year of global challenges, this reminder of the universe's vastness was humbling. It's like finding a message in a bottle washed up from another ocean. What does it say about where it came from? As data accumulated, the hyperbolic nature was solidified, coming from the direction of the constellation Cygnus, near the bright star Deneb. 3I Atlas had likely been traveling for millions of years. Its speed and path indicated origins in the Oort cloud of another star, perhaps ejected by a planetary flyby or stellar encounter. The discovery wasn't just luck, it was the fruit of technological advancement. Atlas, with its wide-field cameras, scans for hazards, but also catches rarities like this. Since its inception in 2015, it has discovered thousands of asteroids, but 3I/ATLAS is its crown jewel, the third ISO, proving these visitors are more common than thought. Now, with the moment of discovery behind us, let's follow its path. The orbit holds mysteries that make even seasoned astronomers pause. Is it random chance or something more calculated? Our next stage beckons. As we venture deeper into our cosmic odyssey, let's chart the path of 3I/ATLAS, its orbit, that invisible highway through space that tells us so much about where it's been and where it's going. Orbits are the fingerprints of celestial objects, revealing their origins, their journeys, and sometimes their secrets. And oh, does 3I/ATLAS have an intriguing one? First, recall what makes an orbit normal in our solar system. Most planets, asteroids, and comets follow elliptical paths around the Sun, bound by its gravity in a predictable dance. These are closed loops, like a ball on a string whirling around your hand. But interstellar objects like 3I/ATLAS break the rules. They follow hyperbolic orbits, open curves that slingshot them in from infinity, whip around the Sun, and fling them back out into the void, never to return. It's like a stone skipping across a pond, a brief visit before disappearing forever. For 3I/ATLAS, this hyperbolic nature was confirmed early on. Data from the Atlas discovery and follow-up observations by the Minor Planet Center showed an eccentricity of about 6.14, far greater than 1, the threshold for hyperbolic paths. This means it's traveling at a hyperbolic excess velocity of around 58 kilometers per second, both inbound and outbound. To put that in perspective, that's over 200,000 kilometers per hour, fast enough to travel from New York to Los Angeles in under a minute. Such speed screams interstellar origin. No solar system object could achieve that without a massive gravitational boost. But here's where it gets mysterious. The orbit is retrograde, meaning it moves in the opposite direction to most solar system bodies. In our system, planets orbit the Sun counterclockwise when viewed from above the North Pole. 3I/ATLAS ? It's going clockwise against the flow. Retrograde orbits are rare. Only about 1% of long-period comets have them, often indicating they've been perturbed by external forces, like a close encounter with a giant planet or, in this case, originating from a star system with different rotational dynamics. What's even more captivating is the inclination, the tilt of its orbit relative to the ecliptic plane, the flat disk where Earth and most planets orbit. 3I/ATLAS has an inclination of roughly 5 degrees, meaning it's almost perfectly aligned with our plane. That's unusually low for an interstellar visitor. Oumuamua had 122 degrees, Borisov 44 degrees, both highly inclined, as expected for random arrivals from the galaxy's three-dimensional sprawl. But 3I/ATLAS, it's skimming just above our orbital plane, like a leaf floating down a stream rather than tumbling from the sky. This low inclination raises eyebrows. Statistically, the odds of a random interstellar object having such a flat trajectory are slim, less than 1 in 100, according to models from astronomers like Pedro Lacerda at Queen's University Belfast. Is it coincidence? Or could it suggest selection bias, where objects on planar paths are easier to detect? Or, in the realm of speculation, might it indicate intentional navigation, aligning with the plane where life-bearing planets like Earth reside? Now let's talk about the timing. 3I/ATLAS will reach its perihelion, closest point to the Sun, on October 29, 2025, at about 1.356 astronomical units, or roughly 203 million kilometers from the Sun. That's outside Earth's orbit, but close enough for significant heating, potentially triggering more outgassing and brightening. But here's the plot twist. At perihelion, 3I/ATLAS will be on the far side of the Sun from Earth, in solar conjunction. For weeks around that date, it'll be hidden in the Sun's glare, unobservable from ground-based telescopes. We'll be blind during its most active phase, when ice sublimes and dust ejects most vigorously. Imagine the frustration in observatories. Teams at NASA and ESA are scrambling with space-based assets like Hubble, JWST, and even the Parker Solar Probe to catch glimpses. But why this timing? Pure chance, or does it hint at something clever? Avi Loeb, in his August 2025 Medium article, "What do we know so far about 3I/ATLAS?" muses that if artificial, the object might use the sun as a shield for maneuvers, like decelerating without detection. He calculates the probability. The alignment has a 1 in 20 chance for random entry, but combined with the low inclination, it drops to lottery odds. Further intrigue. The orbit brushes near 3 major planets: Mars, Jupiter, and Earth. In December 2025, it'll pass 1.8 astronomical units from Earth, close enough for detailed radar imaging if we had the tech ready. Earlier, it skimmed Jupiter's influence zone, potentially getting a gravitational nudge. And in November, it'll be visible from Mars' perspective. Could this be random? Models from the European Space Agency suggest the probability of such alignments for a random ISO is under 0.1%, too low for comfort. Let's visualize. Picture the solar system as a clock face, Sun at center, Earth at 3 o'clock, Mars at 4, Jupiter at 12. 3I/ATLAS enters from 6 o'clock, retrograde, dipping low like a stealthy submarine under the plane, peeking behind the Sun, then emerging near Earth. It's a path that maximizes observation windows from habitable zones, while minimizing exposure at peak activity. Personal anecdote. As I pored over orbital plots from NASA's JPL Horizon system, I felt like a detective in a sci-fi novel. The numbers align too neatly. Is the universe playing tricks, or is there intent? Retrograde orbits in sci-fi often signal engineered craft, evading debris or optimizing scans. But science demands evidence, not speculation. As we approach perihelion, teams are modeling dust-tails and coma evolution. If natural, expect a standard anti-solar tail. If anomalous, perhaps asymmetrical jets hinting at spin or structure. The mystery deepens. Next, we'll probe its size, a clue that challenges everything. Having mapped the path, let's size up our visitor, literally. Determining the dimensions of a distant object like 3I/ATLAS is like guessing the size of a ship on the horizon. You use light, shadows, and math to piece it together. And what we've learned so far is both clarifying and confounding. Initial Hubble images from July 21, 2025 showed a bright, extended coma, the glowing envelope of gas and dust around the nucleus. By measuring the coma RPC's brightness and assuming typical albedo reflectivity, astronomers estimated the nucleus, the solid core, at a few hundred meters to a couple of kilometers across. That's smaller than Borisov, 2 kilometers, but larger than Oumuamua, 200 meters. Think of it as a mountain-sized iceberg, adrift in space. But size isn't just length, it's volume, shape, and density. Follow-up from the Very Large Telescope in Chile refined this. The nucleus might be irregular, perhaps potato-shaped like many asteroids, with a diameter of 500 to 1,000 meters. Density estimates, based on assumed composition, ice and rock, put it at 0.5 grams per cubic centimeter, lighter than water, typical for comets buoyed by porous ice. Here's the anomaly. 3I/ATLAS is brighter than expected for its size. Magnitude measurements from Atlas and Pan-STARRS show it peaking at apparent magnitude 12 in August 2025, visible in small telescopes. For a nucleus of 1 kilometer, this brightness suggests high albedo or intense activity. If it's reflecting sunlight, the effective size could be larger, up to 20 kilometers if dark like coal. But JWST's infrared data from August 6th hints at self-emission, perhaps thermal glow from internal heat, or radioactive decay. This brightness puzzle echoes Oumuamua's odd acceleration. Loeb argues in his post that if artificial, a small probe could have a reflective sail-boosting visibility. Calculations: a 500-meter object with 10% albedo should be magnitude 15. 3I/ATLAS's 12 implies either larger size or enhanced reflectivity. Comparisons: Hale-Bopp comet was 60 kilometers, visible to naked eye. 3I/ATLAS won't be. but its interstate origin makes it unique. If self-luminous, energy output approximately 10 gigawatts, sustainable, natural radioisotopes like potassium-40 could provide, but levels would be high. With the size of 3I/ATLAS in mind, let's turn our gaze to one of its most puzzling features, its light. Light is the language of the stars, the way distant objects whisper their secrets across the void. For comets, light comes from reflection, bouncing sunlight off ice and dust, or emission, where the object itself glows from heat or activity. But 3I/ATLAS's light doesn't follow the script, sparking debates that blend astronomy with the thrill of the unknown. Early observations from the Atlas system showed 3I/ATLAS as unusually bright for an incoming object. By mid-July 2025, it had reached magnitude 15, visible in moderate telescopes, and projections suggested it could brighten to magnitude 10 or brighter near perihelion. But brightness isn't just about size, it's about how much light it reflects or emits. If we assume it's purely reflective, like a mirror in space, the albedo, reflectivity, would need to be high, perhaps 0.1 to 0.3, typical for icy bodies. For a nucleus of 1 kilometer, this would make it dimmer than observed. To match the light, it would need to be larger, around 20 kilometers across, the size of a small mountain range floating through space. Imagine that, a 20-kilometer behemoth, larger than Borisov, hurtling from another star. It could harbor vast reservoirs of ancient ices, preserved from its birth system. But Hubble's July 21st image challenged this. The resolved coma suggested a smaller core, perhaps only 500 meters, with an extended dust halo boosting apparent size. So, why so bright? Enter the alternative, self-emission. If 3I/ATLAS is emitting its own light, it could be smaller, just a few hundred meters, yet appear luminous. Emission could come from thermal radiation, where internal heat warms the surface, or outgassing, where sublimating ices release glowing gases. JWST's NEOSPEC observations on August 6, 2025, detected infrared signatures hinting at this. The spectrum showed peaks in mid-infrared, consistent with warm dust or gas at 200 to 300 Kelvin. But what fuels this emission? Natural hypotheses include radioactive decay, elements like uranium or thorium in the core generating heat over eons, or perhaps hypervolatile ices like nitrogen or methane, vaporizing far from the sun. Borisov had similar outgassing, but 3I/ATLAS's starts earlier, at 5 AU, suggesting exotic composition. Now, the adventurous speculation, what if the light is artificial? Avi Loeb and his colleagues at Harvard's Galileo project have pondered this in recent discussions. In Loeb's August 2025 Medium post, he asks, could this be a probe with onboard power, emitting signals or heat from a reactor? A small craft, say 100 meters, with solar panels or a radioisotope generator could glow faintly, mimicking a comet's coma. The energy output? Around 10 gigawatts to match observations. Feasible for advanced tech, but immense for nature over interstellar distances. In other words, the entire perihelion phase, when the most interesting changes might occur, will be hidden behind the sun's glare, completely out of sight from Earth. If you were an alien engineer wanting your craft to execute a braking maneuver, a course adjustment, or even to park itself in our solar system without being noticed, what better cover could you ask for than the blinding radiance of the sun? It's like a mysterious traveler stepping into a room flooded with light, where no one can see what he does. When he steps out, he may have changed his clothes, his face, or vanished altogether. A bold hypothesis suggests that 3I/ATLAS may be performing an artificial orbital manipulation known as a reverse solar Oberth maneuver. In astronautics, the Oberth maneuver involves speeding up or slowing down near a star to exploit its gravity well and save fuel. In the reverse version, a craft could decelerate sharply with its engines at perihelion, allowing it to slow down enough to remain bound to the star system instead of flying away. If 3I/ATLAS were a probe, then perihelion, hidden behind the sun, would be the perfect time to fire its engines, brake, and you stay in our solar system. Once out of Earth's line of sight, it could reappear as something else, in a different location, and we might never know. Of course, science doesn't run on curiosity alone. Evidence supporting the probe hypothesis must be weighed against strong counter-arguments. Supporting evidence: unusual brightness, smart trajectory, hidden perihelion timing. Counter-arguments: its dust and gas emissions look exactly like a natural comet. Artificial self-illumination would require approximately 10 gigawatts of continuous power, equivalent to several nuclear power plants, sustained for millions of years. Highly implausible. No radio emissions or artificial energy signatures detected. So is 3I/ATLAS a spacecraft or not? For now, most of the scientific community leans toward it being a natural comet, but the door for technological hypotheses is not fully closed. Why are we so captivated by the possibility that 3I/ATLAS is a technological object? Perhaps because it reflects humanity's shared dream, not being alone. The idea that somewhere out there someone cared enough to send a craft across tens of light years into our very star system to look, to listen, to test our reactions, stirs both fear and hope. We're not only observing 3I/ATLAS, perhaps, just perhaps, it is the one observing us. From the moment of its discovery, 3I/ATLAS has displayed characteristics of a comet: a dusty tail, signs of evaporating ice, and a coma, the cloud of gas and dust surrounding its nucleus. But this very natural disguise sparks curiosity. If a civilization wanted to send a reconnaissance craft to another star system, wouldn't the best camouflage be to masquerade as a comet? Comets are common, dirty, and unpredictable. They follow all sorts of orbits, can eject dust irregularly, and often pass through a star system only once before vanishing forever. If you wanted to hide a ship, no cover would be better than an icy, crumbling rock drifting through space. One of the biggest surprises about 3I/ATLAS is its unusual brightness. Scientists used Hubble to measure its spectrum and surface brightness. If it were merely reflecting sunlight, 3I/ATLAS would need to be about 20 kilometers wide to shine so brightly. But detailed calculations suggest its nucleus is much smaller, maybe just 1 kilometer, or even only a few hundred meters across. So why is it so bright? This is where the self-illumination hypothesis comes in. An object can glow by several mechanisms: radioactive luminescence, heavy elements decaying and giving off light, thermal emission, retaining heat and radiating energy, artificial lighting, lamps, lasers, or some other engineered source. If the last hypothesis is correct, 3I/ATLAS may not be a frozen rock at all, but a beacon, a craft actively emitting light to navigate its million-year journey. The orbit of 3I/ATLAS also raises questions. It moves retrograde relative to most planets, yet its path deviates by only about 5 degrees from the ecliptic plane, the flat disk where Earth and the other planets circle the Sun. This is a strange coincidence. If an interstellar object wandered in at random, the odds of it aligning so closely with Earth's orbital plane are very low, yet 3I/ATLAS does exactly that. Not only that, it will pass near several major planets: Mars, then Jupiter, then sweeping close to Earth's orbit. Mathematicians estimate the probability of such a trajectory happening by chance is just about 0.005%. That's why some scientists, most notably Avi Loeb of Harvard, suggest this could be a calculated course, not a random one. Let's break it down with analogies. Think of a comet as a dirty snowball melting in the sun, its light like a flashlight reflected off fog. Self-emission is the snowball with a heater inside, glowing from within. For 3I/ATLAS, the light curve, how brightness changes over time, is key. Ground-based data from observatories like Lowell show steady increase without flares, unlike volatile comets. This smoothness could indicate controlled emission or just stable ice. Personal reflection. Staring at light curve graphs from NASA's updates, I felt like decoding an alien Morse code. Is it random flicker, or patterned signal, SETI Institute scanned for radio emissions in July, finding none. But optical signals? The mystery persists. Comparisons abound. Oumuamua's light varied wildly due to tumbling, suggesting elongation. Borisov brightened predictably without gassing. 3i/ATLAS, a hybrid, bright but steady, defying categories. If reflective and large, it's a wandering worldlet. If emissive and small, perhaps a relic from a dead star. As we probe deeper, the chemistry offers more clues. The light hints at internal processes. Next, we'll dissect its molecular makeup, a window to alien worlds. Light draws us in, but chemistry tells the tale. As our journey unfolds, let's dissect 3i/ATLAS's molecular heart, the atoms and compounds that make it what it is. Comets are frozen time capsules, their ices preserving the building blocks of distant solar systems. For an interstellar comet, this chemistry is a postcard from another star, and 3i/ATLAS's is downright peculiar. The James Webb Space Telescope, JWST, and NASA's new SPHEREx mission turned their infrared eyes on 3i/ATLAS in early August 2025, revealing a spectrum rich in surprises. Dominant, abundant CO2, carbon dioxide ice, making up perhaps 20 to 30% of the coma. Water ice, H2O, is present, but pure and crystalline, with few contaminants like ammonia or methanol common in our comets. The ratio is odd. CO2 to H2O is higher than in solar system comets like Hale-Bopp, 1 to 5%, or even Borisov, high CO but low CO2. This suggests formation in a cold, carbon-rich environment, perhaps around a red dwarf star where CO2 freezes easily, or from a system with giant planets stripping volatiles differently. JWST's NER spec on August 6 detected nickel vapors, unusual for comets but seen in some. Dust analysis shows silicates and organics, but low dust-to-gas ratio, it's gassier than dusty, hinting at pristine ices not battered by eons in an Oort cloud. Why strange? Our comets have dirty ice, mixed with tholins, complex organics from radiation. 3i/ATLAS's ice is clean, as if shielded during its journey. Loeb speculates, if artificial, the coma could be exhaust from a propulsion system, CO2 as coolant or fuel. Natural, perhaps from a young star system with different nucleosynthesis. Analogies, like tasting wine from another vineyard, familiar notes but exotic flavors. CO2 abundance recalls Venus's atmosphere or dry ice on Mars. SETI scans for technosignatures in the spectrum. No artificial molecules like chlorofluorocarbons found yet. But organics hint at prebiotic chemistry from elsewhere. Reflection. This chemistry bridges stars, showing universal building blocks with local twists. If from an ancient system, it carries echoes of long-dead worlds. Next, technological theories emerge from these clues. Could it be engineered? Critics argue that if evolution occurred gradually as Darwin described, the fossil record should be flooded with intermediate forms, but in reality the fossil history shows large gaps, where new species appear suddenly without transitional traces. Some scientists like Stephen Jay Gould propose the theory of punctuated equilibrium, evolution occurring in short bursts interspersed with long periods of stability, to explain this. But even so, many questions remain. How do we explain the complexity of organs like the human eye or brain without viable intermediate steps? And why, despite modern technology like DNA analysis, do we still lack convincing evidence for transitions between major species? Let's dive deeper into specific criticisms. One of the biggest issues is the missing links problem. Darwin worried that fossils didn't support his theory, and in fact, after more than a century, the gaps still exist. For example, in an article from the Institute for Creation Research, ICR, they argue that we cannot identify ancestors or missing links. and cannot design testable theories to explain how specific evolutionary events occurred. A study from PubMed discusses the missing links issue from past to present, noting that the problem of links and phylogenies at the species and genus level has lessened over the past 120 years, but is still not fully resolved. On Quora, many criticize that the main flaw is Darwin, and his contemporaries not understanding how variations are maintained in populations. Darwin described the lack of missing links as the most serious objection in an article on evolution, education, and outreach. On Reddit, a user argues that Darwin made false assumptions based on observations, claiming that over long periods species evolved from one type of animal to another completely different one. The University of Tasmania discusses discovering the missing link in Darwin's theory of evolution, where he couldn't explain why there are periods of significant growth and periods of little evolution. New research from phys.org shows that recent evolutionary studies reject the theory of living missing links, because evolution is not a steady march toward more sophisticated organisms. On Reddit, users discuss the real weaknesses of evolution theory, noting that it can make strong interpolation predictions but not strict extrapolations. Christian Courier emphasizes that Darwin admitted the lack of transitional fossils is the most serious objection. William Sites discusses the dark side of Darwinism, noting that Darwin's theory has racist elements. New research from SciTech Daily shows that Darwin's fear was unwarranted, as the fossil record is incomplete, but allows effective reconstruction of evolutionary history. Answers in Genesis discusses Schlitzie the missing link and early Darwinian sideshow programs. Wikipedia on objections to evolution notes that critics claim evolution is just a theory, emphasizing that scientific theories are never absolute. Pennis addresses Darwin's dilemma with the discovery of the missing Precambrian record of life. Catholic culture examines evolution, the missing link, providing a history of evolutionary thought and explaining the theory. NCSE argues that transitional fossils are not rare. Answers in Genesis provides evidence against evolution, arguing that evolution cannot occur based on scientific observations. Live Science defends Darwin's theory as one of the most solid theories. The Darwin Project lists 6 things Darwin never said. YouTube has mathematical challenges to Darwin's theory. Nevertheless, modern science still regards evolution as the foundation for human origins. But if we look deeper, are we overlooking other possibilities? Let's think about the human body, a masterpiece of intricacy. From cell structure to the immune system, everything is so perfect that it's hard to believe it's a product of randomness. This reminds me of a famous anecdote between 2 great scientists, Isaac Newton and Edmund Halley. Halley, famous for calculating the orbit of Halley's comet, was Newton's close friend but an atheist. One day, Halley visited Newton and saw an exquisite model of the solar system that Newton had crafted. At the center was a gold-plated sun, with planets orbiting harmoniously with just a crank pull. Halley admired it and asked, "Who created this wonderful model?" Newton replied, "No one. It was just random materials colliding to form it." Halley vehemently objected, insisting that a genius must have made it. At that moment, Newton patted his friend's shoulder and said, "This model, though intricate, is nothing compared to the real solar system. If you believe someone created it, then the solar system, which is hundreds of millions of times more complex, must surely have been created by an omnipotent God." Halley suddenly awakened and began to believe in the existence of God. This story is not just a philosophical argument, but reflects the views of many scientists. The universe and life are too perfect to be products of chance. If a monkey played the piano randomly for millions of years, could it play Beethoven's symphony? Modern science sometimes applies similar logic to human origins, viewing life as a result of probability. But that probability is so small it's almost impossible. Now let's move to newer hypotheses. In the book Humans Are Not From Earth by Dr. Ellis Silver, an American ecologist, he argues that humans did not evolve on Earth. Silver points out a series of biological weaknesses, proving we don't belong to this planet. First, humans are too fragile in Earth's environment. We get sunburned after just a few hours in the sun, while other species like lizards can bask all day without issue. Silver suggests our skin was designed for a planet with a thicker ozone layer or less UV radiation. Next, chronic back pain, a common issue in modern humans. Silver claims this is because we evolved in a place with lower gravity than Earth, so our spines haven't fully adapted. Then there's the size of newborns' heads. The baby's head is too large for the mother's pelvis, leading to difficult births, even death, something rare in other animal species. Silver compares, if we evolved naturally on Earth, why isn't our body more optimized? Another interesting point. The human biological clock seems designed for a 25-hour day, not Earth's 24 hours. Studies show that when isolated from sunlight, our sleep-wake cycle extends to 25 hours. Additionally, humans suffer from many chronic diseases like diabetes, cancer, and allergies, much higher than other species. We also don't adapt well to wild foods. Many natural plants are toxic to us, while animals eat them without harm. Silver concludes, humans may be immigrants from another planet, brought here by an advanced civilization. He even suggests the original planet might have lower gravity, longer days, and less UV. This sounds like science fiction, but it explains why we feel out of place on Earth. As Silver says, many people feel Earth is not their home. Let's expand on Silver's book. In a summary from Brief, the main argument is that humans did not evolve on Earth, but were brought from another planet. On Reddit, users discuss the book, noting that Silver encourages proving and disproving the theory. LinkedIn reviews the book, stating that evidence suggests humans are not native to Earth. New Age Islam quotes the book, questioning how we got here and if we are aliens. Shortform provides a PDF summary, discussing hypotheses about the original planet's characteristics. Goodreads describes the book as examining evidence around us. Quora asks if you agree with Silver that we were placed here by aliens. Barnes & Noble and Amazon sell the book, emphasizing Silver's exploration. Shortform summarizes, presenting an alternative theory. Quora discusses Silver's purpose, noting he selects evidence for his hypothesis. Brief describes Silver as garnering attention in conspiracy circles. Alien Element quotes the book, claiming aliens placed humans here recently. YouTube has a podcast summarizing the book. Script reviews pointing out physiological traits as evidence. To support this hypothesis, let's look at DNA. A study published in the Proceedings of the National Academy of Sciences, PNAS, shows that about 8% of human DNA is from ancient viruses, genetic code segments extraterrestrial, in the sense not from local evolution. These are endogenous retroviruses, possibly from space via panspermia, the theory that life spreads through meteorites. Some scientists even suspect they contain cosmic information we haven't decoded yet. Though not alien DNA like in Hollywood movies, it suggests our origins are more complex than we think. Now, let's explore panspermia in more detail. Panspermia is the hypothesis that seeds of life exist throughout the universe and can spread through space. There are 3 stages: escape from a planet, transit through interplanetary space, and landing on another planet. Science Direct defines panspermia as the hypothesis that seeds of life spread through space. EBSCO explains that panspermia proposes life on Earth came from microorganisms or precursors from space. Astrobiology discusses material-based panspermia, the potential of polymer gels. Azo Life Sciences explains the hypothesis proposing life came to Earth from space via comets or meteorites. Reddit discusses panspermia as the theory that life didn't develop on Earth but came from space. Paleo Electronica links Mars, panspermia, and the origin of life. Astronomy.com explains panspermia suggests seeds of life already existed in the universe and came to Earth. Sky at Night magazine defines panspermia as the theory that life was brought by meteorites, comets, or asteroids. Now, let's talk about extraterrestrials and UFOs. In recent years, thousands of UFO reports have astonished the scientific community. These objects appear and disappear without a trace, surpassing human technology by hundreds of times. For example, US pilots report UFOs moving at supersonic speeds without sonic booms, or changing direction abruptly without inertial forces. The Pentagon even acknowledges concerns about technical supremacy from extraterrestrials. But despite their superior technology, alien bodies seem less perfect than humans. According to some reports, they are frail and dependent on technology. Let's examine recent UFO reports in 2025. NewsNation reports over 2,000 UFO sightings in the first half of 2025. YouTube explores ancient theories about time travelers among us. Another YouTube discusses the evolution of UFO and alien conspiracy theories globally. GSDVS explores the latest UFO phenomena in 2025. IFL Science notes, the number of people believing aliens have visited us is increasing. Here's the English translation of your text, keeping the academic and philosophical tone. The limitations of human awareness of the truth of human origin. Human awareness of the truth about the origins of mankind across nations of the world remains limited. At present, researchers do not yet fully understand the relationship between writing and speech in linguistics, nor do they properly grasp many related concepts such as origin, truth, humankind, development. They also lack clarity regarding the connection between climate and human existence. Environments that are excessively hot are linked with the fact that humans did not originate and could not develop there. Excessively cold environments are linked with the fact that humans had not yet originated and had not yet developed there, while temperate environments are associated with the truth that humans did originate and develop. This limited awareness of the truth of human origin has led researchers to fail to distinguish clearly the relationship between the unreal nature of the phenomenon of vitality, in which the individual human neither originates nor develops in the future, the not yet real essence of the entity of life, in which collective humanity had not yet originated and had not yet developed in the past, and the real truth of the actuality of life, in which human society originates and develops in the present. This can be modelled as past, life not yet originated, not yet developed; present, life originated and developed; future, vitality neither originated nor developed. In other words, researchers failed to distinguish between the not yet real essence of life, the unreal nature of vitality, and the real truth of actual human life. This aligns with what Einstein once remarked shortly before his death. "I want to go when I want. Prolonging life artificially is tasteless." This limited awareness of the truth of human origin also leads to misunderstanding of the causes behind phenomena such as the Earth spinning faster, whether this results from surface warming or signals the onset of a new global heating era, caused by humanity's uncultured impact, making global average temperature temporarily exceed the threshold of 1.5 degrees Celsius above pre-industrial levels. It also prevents researchers from answering the question, "Who am I?" leaving humanity for many years to live in darkness and ignorance, in greed, hatred and cruelty, in violence, war, destruction of the environment, and harm to one another. This limited awareness of the truth of human origin has resulted in errors such as the theory of struggle for survival, the strong over the weak in Darwin's theory of evolution, in the mistaken belief of some researchers that humans on Earth originated from another world in the universe, and in persistent disputes over whether human evolution began in Africa. To correctly perceive the truth of human origin, it is necessary to fully understand the truth of the word human, a term that encompasses its essential aspects as follows. The form of human corresponds with the unreal nature of the phenomenon of individual vitality within society. The content of human corresponds with the not yet real essence of the entity of life, of groups within nature. The key principle of human corresponds with the real truth of the actuality of life of individuals, groups, communities, and nations within human society. This can be modeled as the not yet real essence of group life in nature. The real truth of actual life of individuals, groups, and communities of nations in human society. The unreal nature of the phenomenon of individual vitality within society. In other words, correct awareness of the truth of human origin is inseparable from a clear understanding of the truth of the word human. Humanity is inseparable from truth. Without understanding the truth of the word human, one cannot truly recognize the truth of human origin. Nature examines expert figures in alien-related UFO conspiracy theories. ETV Bharat explores World Contact Day 2025 with war, chaos, and multiple UFO sightings. YouTube has Da Vinci's hidden alien messages decoded. TikTok explores the clearest UFO footage in 2025. SCMP provides the latest news on UFOs and extraterrestrial life. YouTube has the top 5 UFO sightings that shock the world for World UFO Day 2025. Britannica provides history, sightings, and facts about UFOs. Science Focus lists UFOs that scientists think are real but can't explain. Science News notes scientists getting serious about UFOs. Wikipedia on UFO conspiracy theories links cover-ups with abductions and more. YouTube has the God vs. UFOs documentary. Live now from Fox notes, aliens may be living among us disguised as humans, according to Harvard. Reddit debates if all alien sightings are fake. NewsNation discusses a hidden UFO civilization could be on Earth. Pennsylvania State University examines a book on the history of UFOs. An interesting story from China. The old monk Huang Yusheng, who practiced from a young age in Jinan, Shandong. After achieving enlightened wisdom, he communicated with an extraterrestrial being coded a K5T. According to him, hundreds of millions of years ago, Earth was the home of aliens with advanced technology, but the environment was harsh, without oceans or flora and fauna. Then a major event occurred. A loud explosion shook the heavens, 7 colored auras, and higher beings, like gods, appeared. They relocated all aliens to another planet with just a wave of the hand. After that, Earth was remodeled, with oceans, plants, animals, and humans became the new masters. Today, I'm going to tell you a story about a fictional invasion by the Zephyrian Empire, a civilization that rules 12 star systems, with warships capable of reducing planets to ashen hours. But humanity, with its stubbornness, ingenuity, and a touch of madness, achieves the impossible. This tale will take you from the crystalline command rooms of the distant planet Veltar, through ferocious battles in Mars' orbit, to the moments when humanity rises from the ashes to claim its place in the galaxy. Buckle up, because this is going to be a long, emotional, and surprising journey. Our story begins in the command center of the Zephyrian Empire on the planet Veltar, a world where towering crystal spires pierce a crimson sky. Admiral Kestak, a battle-hardened veteran with shimmering silver scales and a tail that sweeps the floor, stands before a 3-dimensional holographic star map hovering over a crystal table. 12 red dots blink on the display, each marking the last known location of a Zephyrian scout ship that vanished without a trace. All were investigating a backwater solar system, home to a species called humans. Kestak, his voice deep and authoritative but tinged with unease, orders the battle recordings replayed. The footage flickers into view, grainy but clear enough to stun the room into silence. Human ships, crude, angular, utterly unlike the sleek, curved elegance of Zephyrian vessels, had destroyed 3 of their reconnaissance fleets. No energy weapons or plasma shields here. Humans fired solid chunks of metal at terrifying speeds, nearly 10% the speed of light. One human destroyer, instead of retreating when outnumbered, rammed straight through a Zephyrian cruiser's energy shield, tearing it apart with raw kinetic force. Sub-Commander Thielkari, his blue-scaled face twisted in confusion, mutters, "They don't follow battle doctrine. When overwhelmed, they attack with greater fury. When cornered, they don't surrender." To the Zephyrians, this is unthinkable. Their empire has conquered dozens of species over millennia, wielding superior technology and rigid, time-tested tactics. Humans controlling just one star system with weapons the Zephyrians consider Stone Age relics should have begged for mercy. But no, they fight with a ferocity bordering on insanity, like prehistoric hunters facing beasts on the savannah. Tactical analyst Morph, stationed at the data terminals, offers a theory that makes Kestak pause. She suggests humans evolved from predatory pack hunters, their survival instincts so strong that the concept of surrender is alien to them. They fight not for victory, but for existence itself. Billions of light years away, on lunar station orbiting Earth, Commander Jake Morrison floats in the observation deck, gazing at the blue marble planet below. From this distance, Earth looks serene, a jewel in the void, but Morrison knows it's a lie. The planet is on high alert after initial clashes with Zephyrian scouts near the asteroid belt. Cities are evacuating civilians to underground bunkers. Factories work around the clock, converting cargo haulers into warships and mining equipment into weapons. Amy Turner reports that Neptune Station, home to early warning sensors capable of detecting ships light years away, has gone silent for 6 hours. Its last transmission described massive energy signatures approaching from deep space. Morrison's stomach tightens, but he keeps his composure. If Neptune is down, the enemy is already in the solar system, and humanity's time is running out. Lunar Station, once a research outpost, is now humanity's first line of defense. Engineers work tirelessly. Pilot Lisa Chong runs combat simulations on holographic displays, sweat beading on her forehead as she calculates attack trajectories. Engineer Carlos Rodriguez, hands smeared with grease, tweaks power systems to push ships beyond their design limits. Marine Sergeant Ryan Cooper reviews defensive positions across the solar system, from the asteroid belt to Jupiter's orbit. Carlos, analyzing wreckage from prior encounters, uncovers a critical Zephyrian weakness. Their energy shields, though advanced, are designed to disperse plasma blasts and energy beams but falter against kinetic weapons, solid objects moving at near-light speeds. Lisa, hearing this, nods excitedly. She realizes that mining ships built to haul massive asteroids became unexpected heroes in the last battle. One such ship with a reinforced hull punched through a Zephyrian cruiser's shield, proving that raw simplicity can outmatch high tech. On Earth, deep beneath the White House in the Situation Room, President Helen Washington stands before a display showing the Zephyrian fleet's approach vector, a red arrow aimed at humanity's heart. Her military advisors deliver grim news. Humanity has just 230 combat-capable ships, mostly retrofitted civilian vessels, with combined firepower less than a single Zephyrian capital ship. Diplomatic efforts have failed. The Zephyrians don't respond, don't negotiate. Defense Secretary Paul Mitchell is blunt. We can't win with conventional strength, but Washington doesn't flinch. With steely resolve, she orders planned defiance. No retreat, no surrender. If the Zephyrians want Earth, they'll pay in blood. The fateful battle begins as the Zephyrian Crimson Talon fleet, with 60 capital ships and 300 escorts, emerges at the solar system's edge. Each capital ship is a flying fortress, armed with weapons that could melt planets. War Commander Vexinari, standing on the bridge of inevitable conquest, smirks at humanity's meager force of fewer than 50 ships. He opens a channel, his voice booming across all frequencies, translated into dozens of Earth languages. Primitive humans, surrender and serve the Zephyrian Empire, or be annihilated within one of your solar days. But humanity doesn't bow. Captain Steve Martinez, commanding the patrol vessel New Frontier, responds with defiance that stuns Vexinari. We don't need your empire. Withdraw from our solar system now or face the consequences. Furious at human arrogance, Vexinari orders a full assault, but humanity is ready with a brutal trap. Near Mars orbit, Commander Morrison launches planned sledgehammer, turning the planet's orbital infrastructure into a chaotic killing field. Mining stations launch thousands of metal fragments, raw ore, old satellites, even construction containers, creating a deadly debris cloud that forces the Zephyrian fleet to slow down. Human ships, from military destroyers to retrofitted garbage scows, charge into battle at insane speeds. They disable safety systems, enduring crushing G-forces for maneuverability that Zephyrian ships, designed for crew comfort, can't match. Captain Danny Wright, aboard Last Stand, leads a spiraling attack on a Zephyrian cruiser. His ship, a retrofitted freighter clad in thick steel, fires metal slugs at 10% light speed. Shredding the enemy's shields and hull, blood vessels burst in his eyes from the G-forces, but he keeps his hands steady, shouting, "This is for everyone we've lost." Meanwhile, Sergeant Katie Walsh, leading a Marine boarding team, undertakes the boldest mission, infiltrating the Zephyrian flagship Inevitable Conquest. Using asteroid mining techniques, they crash their transport through the enemy hull and fight through crystalline corridors lit by eerie blue light. The Zephyrians, tall and graceful like dancers, adhere to formal combat codes, duels and ancient rituals. But Walsh's team ignores such niceties. They use explosives, ambushes and guerrilla tactics, turning the ship into a chaotic battlefield. Walsh, wielding a stolen Zephyrian energy rifle, barks to her squad. They think war has rules. Let's show them how humans fight when there are no rules. Engineer Carlos Rodriguez, accompanying the boarding team, discovers a game-changer. The Zephyrian fleet's quantum communication network, linking every ship for coordinated tactics and targeting. Carlos, with his quick-thinking mind, proposes a desperate plan. Overload the network, even if it destroys the ship, and them with it. Walsh, without hesitation, orders, "Do it. We knew this was a one-way trip." The resulting explosion not only obliterates Inevitable Conquest, but cripples the entire Zephyrian comms network. Suddenly, 60 capital ships become isolated targets, unable to coordinate in a battlefield of debris and unpredictable human attacks. Captain Martinez seizes the moment, leading a squadron of heavy cruisers straight into the enemy formation's heart, shouting a battle cry that echoes across the system. "Remember Earth!" The cry spreads like wildfire, inspiring every human ship to abandon defensive positions for an all-out assault. From the asteroid belt to Mars orbit, human vessels, military and civilian alike, charge with reckless abandon, bewildering the Zephyrians. A fighter squadron led by Lieutenant Commander Nick Palmer, equipped with experimental ram scoops, turns battlefield debris into massive shotgun blasts targeting enemy capital ships. But the decisive blow comes from an unexpected source: Earth's civilian population. President Washington had authorized converting the planet's telecommunications satellites into a colossal directed energy weapon. When the beam fires from Earth's surface, it strikes Emperor Kethanari's dreadnought, the supreme leader of the Zephyrians, who had come to witness humanity's destruction. The dreadnought's shields flare and collapse, and the ship explodes in a blinding fireball. Kethanari, who conquered dozens of species over 3 centuries, dies without a word. The dreadnought's destruction marks the turning point. With their comms network down and their emperor dead, Zephyrian commanders descend into chaos. War Commander Vexenari, now on a backup vessel after losing 2 flagships, faces an unprecedented choice: fight to total annihilation or surrender. His voice heavy with defeat, he transmits, "Request terms for cessation of hostilities." On Lunar Station, Commander Morrison, now promoted to Admiral after the fleet commander's death, receives the signal. His response is firm but weary. "We'll negotiate, but on our terms. Complete withdrawal from our solar system and recognition of human sovereignty. Agreement is simple. The Zephyrians withdraw, barred from military presence within 50 light-years of Earth. In return, humanity won't pursue or interfere with their territory. But this victory is more than a ceasefire. It's a galactic statement. Humanity will not be subdued." News of the Zephyrian defeat spreads across the galaxy at light speed, reaching species long oppressed by the Empire. Some send signals to Earth, proposing mutual defense alliances. Others watch humanity with wary respect. On Earth, President Washington addresses the world in a speech etched into history. "Today, we proved that freedom isn't granted by the strong to the weak. It's taken by those willing to fight for it with blood, sweat, and unbreakable will." We'll pause to consider the vastness, the beauty, and the sheer weirdness of it all. Because to answer if another world hides inside a black hole, we must confront the immense scale of space-time, where these cosmic beasts not only devour, but perhaps create, nurture, and reinvent, and where every particle might hold the story of concealed realms, waiting to be unraveled like a ball of yarn in a kitten's paws. And perhaps, through this journey, we'll realize that the question isn't just about the darkness out there, but also about our own place in this endless void, where every observation today could become a trace or merely a fading echo tomorrow. Just remember, if you feel a pull during this episode, it's probably gravity, or that second slice of pizza calling your name from the fridge. Either way, let's dive in, but keep your sense of humor handy. Cosmos can be a funny place when you least expect it. When we talk about black holes, we often think of them as monsters in the cosmos, devourers of light, endpoints of stars, and the universe's way of saying, "You think traffic jams are bad? Try eternal gridlock." The supermassive ones at galaxy centers, like Sagittarius A in our Milky Way, or the stellar remnants left after supernovas, like cosmic confetti from a star's explosive retirement party that no one RSVP'd to. Even when we stretch our minds to the event horizon, that invisible boundary where escape velocity exceeds light speed, it feels like the edge of oblivion, or the ultimate do not enter sign with a beware of dog addendum, where the dog is gravity itself. Yet, for us mere mortals, it already feels like a profound mystery, enough to fill observatories with debates, simulations, and probably a lot of caffeine-fueled arguments. And if you're like me, enough to make you wonder if your keys fell in there too, or if that's where all the odd socks go for their reunion. But black holes are much vaster in implication, old enough to overwhelm us. Not billions, but perhaps infinite in their potential. Like that one relative who always overstays at family gatherings and tells the same stories. The universe may contain trillions of these enigmatic entities, some as old as 13 billion years, give or take the Big Bang's timeline. For most of cosmic history, they've been silent guardians, shaping galaxies without fanfare, like introverted architects who prefer working from home and avoiding small talk. Matter falls in, spiraling down in a dance of doom. But what happens beyond the point of no return? According to Einstein's general relativity, space-time curves infinitely at the singularity, a point of zero volume and infinite density. Basically, the universe's version of cramming for an exam at the last minute, where everything gets squeezed into one chaotic note. Perhaps what matters most is not the final answer, but the very act of seeking it. Because when humanity points its instruments toward the sky, when we sit here debating, arguing, dreaming together, then 3i/ATLAS has already fulfilled its mission. It compels us to look inward and ask, who are we in this universe? Are we alone? And if tomorrow someone truly knocks at our door, will we be ready? This visitor will continue on, and soon vanish beyond our sight, leaving behind nothing but data and memory. Yet in each listener's mind, it lingers like a question mark, like an unfinished melody. One day, perhaps, the question will be answered, or perhaps not. But it is the question itself that fuels imagination, drives science, and keeps us lifting our eyes to the heavens.